Assalamualaikum. We are part 5 from group 11 are here to give a brief explanation about our experiment 5 gas chromatography. And these is our team members. Hi, my name is Amira. I would like to give some brief introduction about our topic, which is gas chromatography. What is gas chromatography? Gas chromatography, or GC, is an analytical technique used to separate volatile compounds based on differences in their boiling points and interactions between the stationary phase. In GC, a vaporous sample is transported through a column by an inert carrier gas such as helium or nitrogen, allowing separation between the normal phase and the stationary phase. In this experiment, GC was used to determine the retention times of N-butanol and 2-propanol, and to identify the components in standard mixture and unknown sample. Also, to assess the effect of temperature on a retention time and resolutions.
Hi, my name is Nurin and I'm going to talk about the objective of this experiment. There are 4 objectives of gas chromatography experiment. Firstly is to determine the retention time of N-butanol and 2-propanol. Retention time is the time taken for a compound to travel through the GC column. Each compound has specific retention time under fixed temperature based on how long a compound takes to elute. Next is to identify the components present in a standard mixture based on the retention time. This can be done by comparing retention time of standard mixture with the retention times of N-butanol and 2-propanol. Moreover, is to identify the components present in an unknown sample. We can compare both retention times of unknown sample and the standard mixture, matching retention time meaning same compound. Lastly is to determine the effect of temperature on retention times and chromatography resolution. What is chromatography resolution? It measures how well 2 peaks are separated.
Next procedure, A. Sample handling. First, the shrink was rinsed before it was filled with the sample. The volume of the sample was sometimes more than the required volume. It was ensured that there were no air bubbles in the shrink. To remove any air bubbles, the shrink was tapped gently. Second, the shrink was held out vertically, needle up, and the plunger was pushed to the required volume at eye level. The excess samples was removed using a tissue. B. Experimental. The gas chromatograph was set up by configuring the oven, injector, and detector temperatures according to the experimental method to ensure stable and reliable operating conditions. Individual components, the standard mixture, and the unknown samples were loaded into the autosampler, allowing consistent and automated injection throughout the analysis. The samples were injected automatically by the autosampler, and the retention times obtained from the chromatograms were used for the identification of each component. Next, the column and the oven temperature were varied systematically in order to study their effects on the retention time and resolution of the separated components. Detection of the eluted compounds was carried out using a flame ionization detector (FID), and the chromatograms were recorded for each analytical run. Lastly, calibration was performed using a standard mixture, and the chromatographic data were analyzed to identify and confirm the components present in the samples.
Based on the data obtained from chromatogram, at 70 degrees Celsius, the standard mixture showed 2 peaks of retention time at 2.673 minutes and 5.817 minutes. 2-propanol eluted at 2.707 minutes and N-butanol eluted at 5.969 minutes. So the peak at 2.7 minutes corresponding to 2-propanol and the peak at 5.9 minutes corresponding to N-butanol. Further, the unknown sample at 70 degrees Celsius show a peak at 5.966 minutes. This retention time almost identical to N-butanol. To conclude, the unknown sample most likely to only contain N-butanol since there are no peak that corresponding to 2-propanol. Lastly, to observe the effect of temperature on retention time and chromatographic resolution, we can compare the retention times of standard mixture at multiple temperatures, which are at 70, 100 and 140 degrees Celsius. The data show that they are decreasing in retention time as the temperature increases.
Hi, my name is Mara and I would like to talk about the discussion of GC experiment. So, for this gas chromatography GC experiment, the result shows the effect of temperature on the retention time of alcohol compounds. It also allows identification of the unknown sample by comparing the results with known sample. At 70 degrees, the standard mixture produced two distinct peaks with retention times 2.673 minutes and 5.817 minutes. Meanwhile, for 2-propanol, the retention time is 2.707 minutes and for N-butanol is 5.969 minutes. By looking at this, it confirms that compounds with lower boiling points elute earlier than compounds with higher boiling points. The unknown sample was analyzed at 70 degrees and the retention time is 5.966 minutes, which closely to the retention time of N-butanol, which is 5.969 minutes. The difference of retention time is less than 0.01 minute, so it considered as N-butanol for the unknown sample. The effect of temperature on retention time for the standard mixture can be clearly observed when it is analyzed at different temperatures. At 100 degrees, the retention time decreased significantly to 0.799 minutes and 3.284 minutes. Meanwhile, at 140 degrees, the retention times further decreased to 1.954 minutes and 2.240 minutes. When the temperature increases, it reduces the interaction of analyte and stationary phase and causing the compounds to elute faster. However, at higher temperatures, the separation between peaks becomes smaller and has potential to reduce resolution. Overall, the results indicates that lower temperatures provides better separation but has longer analysis system, while higher temperature reduce the retention times at the expense of peak resolution. Identification of the unknown samples confirmed to be N-butanol. This demonstrates the effectiveness of GC to identify the compound when appropriate standards are used. Many precautions must be taken to minimize errors such as injection volume, column condition, and slight temperature fluctuation.
Hi, I'm Fadlin Fazana. Now I will explain the conclusions based on the result obtained from this experiment. Gas chromatography was successfully used to identify the unknown sample at the column temperature of 70 degrees Celsius. The standard mixture produced two peaks with retention time of 2.707 minutes for 2-propanol and 5.969 minutes for N-butanol. The unknown sample showed a retention time of 5.966 minutes, which is very close to that of N-butanol. Therefore, it can be concluded that the unknown sample is most likely N-butanol. Furthermore, the unknown sample was identified as N-butanol by matching its retention time with that of the standard, meeting the objective of identifying an unknown compound using GC analysis. The result also showed that increasing the column temperature shortened the retention times, indicating that temperature has a significant effect on retention time, which is TR, and resolution RS. These observations support the objective of studying the influence of operating condition on chromatography separation. Saya tak sempat cakap je. Okay. The result also showed that when the column temperature was increased from 70 degrees Celsius to 100 degrees Celsius and 140 degrees Celsius, the retention time becomes shorter. This indicates that higher temperature allow compound to move faster through the column, affecting the separation process. The objective of this experiment was successfully achieved. The retention time of N-butanol and 2-propanol were determined using gas chromatography, fulfilling the objective of understanding compound separation based on retention time. The components in the standard mixture were identified by comparing their retention time, which demonstrate the effectiveness of gas chromatography for qualitative analysis. In addition, other analytical instruments can be used to support compound identification. For example, Fourier transform infrared spectroscopy, which is FTIR, can be used to identify functional group present in the sample. High-performance liquid chromatography, which is HPLC, can be used for the separation of non-volatile compounds. And lastly is mass spectrometry, can be used to determine the molecular mass and structure of the compound, providing more accurate identification.